All right. So let's see. We're ready for page. I tore my room up yesterday looking for this. And it was just tucked away in here. And you know what? I don't even need it now. Recycle. Are we on page 547 now? Okay. Okay, so we're looking at area of oblique triangles. Oblique is any triangle that's not a right triangle. Okay, it's wrong. It's not right. Okay, any triangle that's not a right triangle. All right, so look at the triangle that we have here. A couple things I just want to draw your attention to. Okay, side A is across from angle A. So you've got the big A is the angle and the little a is the side. And then side B is the little b across from big B. So big A, little a, what begins with A? Does anyone know?
What?
It's Aunt Annie's alligator. Just so you know. Dr. Seuss. No? Anyway. All right, and H is the height. It's also called the altitude. I think that you know these things, just like it may be tucked away in your brain and you forgot. So height and altitude of a triangle are the same thing. And remember, the altitude of the triangle has to meet the base at a right angle. Base and height always have to meet at a right angle. All right, so think back from geometry. What's the formula that you use to find the area of a triangle? But use the letters from this triangle. How would I find the area of this triangle?
Is it 1/2 base times height?
Okay, it's 1/2 base times height. This base is A, and this height is H. So we're going to say 1/2 AH. That's how we're going to write it. Because what we're going to try and do is rewrite it in terms of trig ratios. So let's fill in what we know. We know that B, or AC, is 9. A, or CB, is 17. And the measure of angle C, right here, is 67 degrees. All right, so using the formula from geometry, what do we not know? After all they just gave us, what do we not know?
Height.
We don't know the height. We don't know H. Okay? Use a trig ratio to find H. You know 67. Are you going to use 17 or are you going to use 9?
9.
Why?
So 17 is C through B.
Right. See, you've got this little, if you're just looking at H, you've got like this little baby triangle within the triangle, and it's a right triangle. So if I'm trying to find, and remember, our trig ratios are for right triangle trig. They go back to right triangles. So even though they gave me 17, I'm going to use 17 later on maybe. But for right now, to find H, this is the triangle that I'm looking at right here. Okay. I'm going to leave you to it. Find H. Okay, we said
These two are actually F, right?
All right, what'd you get? Or how'd you get it?
Do this sin
Sign.
sign. Oops.
We don't sin. Not in here. You sin on your own time. All right, sine of what?
67.
Okay. Equals what?
Height over 9.
Okay. So then height would equal 9 times the sine of 67, which is what? Let's go one more. 8.285. On the AP exam, you have to go 3 decimal places. So just getting that in practice now, because next year in calculus you'll lose points on your test. If you truncate it, if you chop it off at 2, you lose a point. You can't afford that. You can't afford it. Now find the area of the triangle. Okay. So area is 1/2 base times height or if we wanted to be super exact, we could say 1/2 base times 9 times the sine of 67 degrees. Because remember, this is rounded. We just had a talk about where we're going to round it. We're going to round it at 2 or we're going to round it at 3. Find these two answers. What'd you get for this one?
70.423.
And what'd you get for this one?
70.411.
Right. Exactly.
So which one do you go with this one?
We're going to go with this one. And I'm going to, and down here we're going to see how you can do it with actually like any two sides. So let's derive an alternate formula, because this one, we knew this one because we had all this information up here and it kind of led us through. So let's come up with an alternate formula for the area of a triangle if we're given two sides of the triangle and the angle between those two. So basically we're looking at side, angle, side. Okay, side, angle, side. And then test the formula, which we kind of already done, but that's okay. I want to do it anyway. So we know that the sine of C would be equal to H over B. That's what we just did, right? So that means H equals B times the sine of C. Well, what if they gave us B? The sine of B would equal H over C, because see that we're looking at this right triangle over here now. So that means H would equal C times the sine of B. But for both of these triangles, what's the base? For this, if I'm going with this angle or this angle, what's the base? How does this meet? How does H meet? It meets at a right angle with A. So for both of these, the area would be 1/2 times A times either B times the sine of C, or if I had the other one, 1/2 times A times C times the sine of B. Well, what if I drew one here? Well, then that one would be 1/2 times C times B times the sine of A. Basically, the area is going to equal 1/2 the product of the two adjacent sides times the sine of the included angle. See, for each of these, it's A times B sine of C, A times C sine of B, C times B sine of A. So it's the product of the two adjacent sides times the sine of the included angle. What does it mean when it says included angle? Like the angle doesn't want to be left out, it wants to be a part of the group. What does that mean, included angle? What is an included angle? What's an included angle? If this is the two adjacent sides and the included angle, A and B are adjacent sides and C is the included angle. A and C are adjacent sides and B is the included angle. Oh, you can't see that. B and C are adjacent sides and A is the included angle.
Oh, it's just the angle in between the sides.
Right, it's the angle that's in the middle. It's the angle between the two sides. That's an included angle. That's what that means. So the product of any two sides and the sine of the angle that's between them. That's how you can find area of a triangle if it's not a right triangle. All right, let's solve an oblique triangle. All right, using angle C, find an expression for H in terms of B. So if I'm standing on C and I'm trying to solve for H in terms of B, what are H and B in relation to C? Opposite and hypotenuse, so that's going to be sine. So the sine of C equals the opposite over hypotenuse. But it wants me to solve for H, so H equals B times sine C. Okay, you try to do the same thing for angle B. Do the same thing for angle B. Matthew, they're freezing to death all day, and they're wearing shorts. What'd you come up with?
Equals C times this sine of B.
That is correct.
Sorry.
I would have to send you out of here. All right. If both expressions above are equivalent to h, then what must be concluded about the expressions themselves? If this equals h and this equals h, then what do we know about those two things? They equal each other, right? B times the sine of c equals c times the sine of b. Okay, now we're going to try to derive a relationship between an angle and the side across from it. Okay, if I divide this by b, what do I have to do over here? Divide by b. If I divide this by c, what do I have to do over here? Divide by c. And look what we're left with. Sine of c over c equals the sine of b over b. Now, since they're just letters, and you can put whatever letter you want on whatever angle you want, the law of sines says the sine of angle A divided by side A is equal to the sine of angle B divided by side B, which is equal to the sine of angle C divided by side C. That is the law of sines. All right, you can use the law of sines to find all missing sides in a triangle. Triangle ABC, measure of angle B is 130, C is 11, and B is 15. Solve the triangle. First of all, sketch it out. B is 130, C is 11, B is 15. So we need to find side A, measure of angle A, measure of angle C. You all right? Okay. All right, so here's what we do. We know this relationship right here. So that's going to be like our foundation. We're going to put every other relationship in this triangle on that one. So the sine of 130 is to 15. Since I know this side right here, I'm going to say as the sine of C is to 11. How do you solve that? How do you solve a ratio? Or a proportion? Cross multiply. I have 11 times the sine of 130 equals 15 times the sine of C. So I'm going to divide by 15. So the sine of C equals 11 times the sine of 130 divided by 15. But that doesn't really give me C. C actually would equal the inverse sine of 11 times the sine of 130 Bless you. That's why you cover your mouth. That's why you use your chicken wing. All right, so measure of angle C is 34.178 degrees. So the measure of angle A is going to be 180 minus 130 minus 34.178. So it's 15.822 degrees. I'm going to wait just a second because we still need to find side A. Side A, I'm going to use sine of 130 over 15 equals the sine of 15.822 over A. Cross multiply and divide. I'm running out of room here. So, you know, I went through like every single step right here. That's not happening right here because I just got like that little smidgen of space left. So A would equal 15 times the sine of 15.822 degrees divided by the sine of 130 degrees. Five point 5.339. All right, so that's law of sines. In order to apply the law of sines, what combination of information with a triangle must be known? There's one thing for sure that you have to know to set up that ratio. Does anybody know?
An angle on the side.
An angle and its opposite side. You have to know at least one angle with the side across from it. Yeah. What doesn't work? Well, if I have to know at least one angle, side, side, side's not going to work. And if I have to know at least the side across from it, angle, angle, angle is not going to work. And if I have to know one angle and I have to know the side across from it, side, angle, side will not work. But that's okay because there's more. We also have a law of cosine. We're not going to derive the law of cosines. I'm just going to give it to you. It relies really heavily on Pythagorean theorem. And it looks confusing, but we're going to talk about it for a second, and you're going to say, oh, that's not really hard to memorize. Law of sines is super easy to memorize. If you can't remember law of sines, like if you can't memorize that one, we need to have a chat about what your extracurricular activities are, okay? But once you kind of look at law of cosines, you're going to see it's not that hard to remember either. So it starts out a squared equals b squared plus c squared minus 2bc times the cosine of a. Like, that's longer than my arm. It's okay. Calm down. B squared equals a squared plus c squared minus 2ac times the cosine of b. You kind of see a pattern here. So what do you think c squared is going to equal?
A squared plus B squared.
A squared plus b squared minus
2AB.
Times the cosine of
C.
yeah. So you see how it's like that. That's kind of confusing, but it's not, because the one that you're looking for is always your cosine at the end. The other two are squared and added together and subtracted and multiplied by 2. So once you get the kind of the pattern down, it's not so bad. All right, so we have this information here. And then sometimes you have to use both of them together. Like, you'll have to use law of cosines for just a minute, and then you can use law of sines once you start finding stuff. You don't have to use the same one all the time. So let's solve ABC, triangle ABC here for this one. How much time do we have? Yeah. ABC, 6. So this is a side, side, side. Trying to solve the triangle, which means I have to find all the other missing parts. Why don't we just start with angle A? So I'm trying to find A, so I'm going to use this one right here. So A squared equals B squared plus C squared minus 2 times B times C times the cosine of A. All right, that just came straight off the formula. That's it. I'm going to do a little bit of arithmetic. So let's see, that's 36 equals, see, what is 16 plus 81? 97 minus 72 times the cosine of A. That's just math. 16 plus 81 is 97. 2 times 4 times 9 is 72. That's all that has been done so far. I'm going to start solving. I'm going to subtract 97 minus 97. That's going to equal negative 72 cosine of A. What is 36 minus 97? Negative 61.
Yeah.
Okay. So I'm going to divide by negative 72. Except I'm not really. I'm going to leave it as 61 over 72 equals cosine of A. So that means the inverse cosine of 61 divided by 72 equals A. So that's 32.089. Now, at this point, you have two choices, because you still have two more angles to find, but now you know a side, two sides, and an included angle because you just found A. So you could switch over and start using law of sines now if you wanted to. But I think we need to practice law of cosines one more time. So let's do law of cosines again, just for the practice. And then when you're doing these on your own, you can do it however you want. But let's do one more law of cosines. Let's find B. Let's find angle B. Okay, tell me what to write to find angle B.
4 squared.
Mm-hmm.
Equals 6 squared. Plus 9 squared.
Mm-hmm.
Minus 2 times 6 times 1 times the cosine of B.
Exactly. Exactly. So it's 1636 plus 81 is 117. It's 108. So just did my arithmetic and I got 16 equals 117 minus 108 cosine of B. So what do I do now?
Subtract 117.
Subtract 117. And I get a negative 101 equals a negative 108 cosine of B. Now what should I do?
Divide by negative 1.
Divide by negative 108. And basically what I'm looking at now is the inverse cosine of 101 over 108 equals B. And that just goes in your calculator. .742. And then how can I find C?
Just add A and B together
Mm-hmm.
and subtract it from 1.
Right. What is that out of 180? .127.169 degrees. It's not difficult math. It's like tedious, a lot of little steps, but it's not hard to do. If you don't have a calculator, it's hard to do. I would not want to wish this on anyone without a calculator because you'd have to use like a chart to get your sine and cosines and stuff. And that would be awful. So anyway, all right. So we're not going to do this one together. Look at 62's homework, or 61 and what is today? Okay, this is the page you did last night, right? Okay, so we're looking at these two pages right here. All right. Okay, so you've got some word problems. We always have to have a ladder leaning against the house. I'm not really sure why. In calculus, we're going to have a ladder leaning against the house, but it's going to be sliding down the house. It's going to be sliding down the wall. Yeah, so it's dangerous. Calculus is dangerous. You got to have a spotter because you're going to fall. But we always have this problem. And then you're finding the area. Make sure you draw the triangle. And then you have to solve the triangles. And it even says you might have to use a combination of the law of sines and the law of cosines. So it's just the 2 pages, right?
Yeah.
That's it? Okay. All right, there you go. Let you get started.